Another way to solve systems of equations is by elimination. So again, we have two variables, x and y, which means we need two equations to solve it. And what you're trying to do is you're trying to add straight down and have one of the variables get eliminated. So if you follow straight down, 2x plus 3x would give us 5x. Now when we add 2y, so a positive 2y plus a negative 2y, these actually cancel. Equals, and then we've got negative 2 plus 12 is 10. Now we solve this just like a regular equation, divide by 5, so x equals 2. Now again, we're only halfway done because we've only solved for x. We still need to solve for y. So we're going to plug this into either one of these equations. It doesn't matter. Either way, we'll get the same answer. So I'm just going to plug it into this one, and instead of x, I'm going to plug in 2. So we've got 3x minus 2y equals 12, and I'm going to plug in the 2 for x. So then 3 times 2 is 6, minus 2y equals 12. Subtract 6 from each side. Negative 2y equals 6, divide by negative 2, y equals negative 3. So now we've got our x and our y, and we write it as an ordered pair, 2, negative 3. Now unfortunately, it's not always so clean and set up for you. So you can get a problem like this, where when you add straight down, 3x and x would be 4x, negative y and 2y would be y. So neither one canceled out. So what you need to do is you need to multiply one of the equations until something will cancel. So what that means is we have a 3x and an x. So in order to get these to cancel, I would need this to be a negative 3x. So I could multiply the whole bottom thing by negative 3. Or if you look at your y's, I've got a negative y and I've got a 2y. I would need this to be a negative 2y. So I'm going to multiply this whole top row by 2. So each piece. So when I do that, 2 times 3x is 6x. 2 times negative y is negative 2y. And 2 times 2 is 4. So now, because I multiplied every piece by 2, essentially it's the same equation. But now, when we add straight down, we've got x plus 6x is 7x. And now, 2y and negative 2y will cancel. So now we have eliminated one of the variables. And then 3 and 4 would give us 7. Divide by 7, so x equals 1. Again, we're only halfway done. We need to plug it into one of our equations. So I'm going to bring this up and plug this x in. Now that I found x, I'm going to plug it in here for x. So we have x plus 2y equals 3. And instead of x, I'm going to plug in a 1. So 1 plus 2y equals 3, minus 1, 2y equals 2, divided by 2, so y equals 1. And now I need to write it as an ordered pair, x, y, so 1, 1 is our solution to this system of equations. When it comes to solving systems of equations, there are several different methods. One of the methods is substitution. So the idea here is that you have two different variables. You have an x and a y, which means you need two different equations to solve them. So this first method, you substitute one variable for another. So here we know that y equals 2x plus 4. So because we know what y equals, y is this chunk right here, we can substitute that into the other equation for the y. So we can replace the y with what it's equivalent to. So we're going to take this piece and plug it in right there for the y. So plugging it in, we have 3x plus, now instead of y, I'm going to write what y is equivalent to. So plus, I'm going to plug in 2x plus 4 equals 9. So I've substituted this in for the y. Now I'm just going to simplify. So 3x plus 2x plus 4 equals 9. Combine my like terms, so that's 5x plus 4 equals 9. We need to minus 4 from each side. That goes away. We've got 5x equals 5. Divide by 5, x equals 1. Now we're only halfway there because we've only found one variable. So what I need to do now is I need to go back up to my equations, and I'm going to plug x in to solve for y. You can plug it into either equation, but the top one would be easier. So I'm going to take my top equation and say y equals 2x plus 4. Now what I'm going to do is say y equals 2, and instead of x, I'm going to plug in what I know x to be. So I'm going to plug that in for x. So I'll plug in 1 plus 4. That means y equals 2 plus 4, or y equals 6. So now we have our x and our y, and we write our solution as an ordered pair. So we write it as 1, 6. You write x first, then y. So 1, 6. And that is our solution to this system of equations. The second thing that might happen is you might get a system of equations that looks like this, where they haven't already solved it for you. They haven't told you what x equals or what y equals, so you need to rearrange it a little bit. So looking at these two equations, the easier one to rearrange is this bottom one, because x is already by itself. So I'm going to try and isolate x by subtracting 7y from each side. So that will remove it from this side, and now x equals 19 minus 7y. So now that I know what x is equal to, I can take this piece and I can plug it in up here for x. So I'm going to take this and I'm going to plug it in for x. So we've got 2 times 19 minus 7y plus 3y equals 16. So I just plugged x in up here. Now we need to distribute this. So that is 2 times 19, 38, minus 14y plus 3y equals 16. Combine like terms. So we've got 38 minus 11y equals 16. I need to subtract the 38 from both sides. So that goes away, and we've got negative 11y equals negative 22. And now I need to divide both sides by negative 11. So y equals 2. Again, we're only halfway there. We've got our y, but we still need the x. So I can plug it into any of these equations, and I'll get the same answer, but I want the one that's easiest, which is this one. Because all I have to do is plug in y, and it'll tell me what x is. So I'm going to use this equation, x equals 19 minus 7y, and instead of y, I'm going to plug in 2. So we've got x equals 19 minus 7 times 2. X equals 19 minus 14, so x equals 5. And again, I need to write this as an ordered pair, so I write it x, y. So we've got 5, 2, and that's our answer to this system of equations.